This is topic 77, so this is a continuation about slope fields, and then we're going to cover some other stuff. So if you look at it, hopefully what you notice from the homework, alright, is that if you have a drawing and the derivative just has an x and on no y, so meaning it only depends on x, then all the slopes should be the same vertically, alright? So notice that all the slopes right here vertically are the same, so you have the same slopes right here. So vertically, again, you have the same slopes. Now, you also had one like this in the homework. If you have a derivative that only depends on y, such as this one, then all the slopes should be the same horizontally. So horizontally, they should be parallel if you're looking at them horizontally. So the slope should be the same. Okay, so hopefully you notice some of that. Now, if it has x and y, then that depends on two things. So in order for you to match this, so the easiest thing to do is for you to try to eliminate some of these choices. Now, if you look at questions, for example, let's see, examples 1, 3, and 4. I'm sorry, 1, 2, and 4. Right, if you look at all of those, these right here only have y's, which means they're going to be the same horizontally. All right, so it should be the same horizontally. Now, 3 is the only one that has both x's and y, so this one right here is you're going to be looking for a graph that is not the same horizontally. So notice, for example, here, you kind of look the same, but after that it's really different, all right, once you get past this point. So this right here must be C. Again, the reason I'm able to tell is because the slopes horizontally are not the same. And if they're not the same, this must depend on both x and y, and it does. Alright, now the next one, the easiest thing for you to do, I mean, you can, I guess, try to plug in numbers here if you wanted to, but notice that right here, if I'm looking at 0, meaning on the y is equal to 0 on the x-axis, alright, you should have a horizontal slopes. Now this one right here looks like it has some horizontal slopes here just by looking at the slope fields here, but you also have one here. So it's probably not that one, and the same thing with this one, you also have one here. But as you get down to this one, notice that this one right here, as you're going kind of like this, okay, this must be your answer because it looks like as you get closer to this x-axis where y is equal to 0, then the slopes are horizontal. So this must mean that this would be D, okay? Now the next two, the easiest way to do that is to notice that if I say that y is equal to 0, right, so yeah, y is equal to 0 here and here, the whole thing is 0. So you should have some horizontal some horizontal slopes at y is equal to 0, which is the x-axis, okay, like that. Or if you look at it, what would make this 0? Well, what would make this 0 is if I plug in 100 for y, right, I would have 100 over 100 would make it 1. 1 minus 1 is 0. So you're going to have a horizontal slopes both at the y is equal to 0 line and also at y is equal to 100. And if you look at it, you have both of these right here. They both have these little horizontal slopes right here. But notice that just by looking, these are the dimensions, by the way, of that window. If this window right here, the y is 50 by 200, negative 50 by 200, this looks like it's kind of halfway in between, so this must be the one that's 100. Alright, so this would be B, and therefore this has to be A. And again, notice by the same logic, if y is equal to 0, you have horizontal slopes at the y is equal to 0 line. But also on this one, y would have to be 150 to make this whole thing 0, which means the slope will also be 0 at y is equal to 150. And if you notice, this one's higher than this one, alright? So if anything, you should notice because of that. So I kind of already said all this, but I'm going to write it in case that somebody's looking at my notes. I said note that, let's see, A, B, and C slopes are the same, and by the same I mean the slopes are the same horizontally. And graphs A and B have two zero slopes. And again, those zero slopes are located at y is equal to 0, which is the x-axis, or and depending on which one you're talking about, at 100, y is equal to 100, or y is equal to 150, like that one. Okay, so let's go to the back here. That's all really we're going to cover about slope fields. Now we're going to cover something slightly different, all right, like this. Now, on this one right here, give me just a second. On this one right here, I kind of want to do it a kind of strange way, it may seem at first, but this is going to lead into separation of variables, which is the next section. So they're asking us to find the solution of the differential equation if y is equal to 3. Well, if x is equal to 3, y is 5 when x is 3. So if I have that, I cannot plug that in here because this is a derivative. I need to get back to the original equation, y is equal. So in order for me to do that, I'm going to have to integrate this. Now I'm going to do something that's perhaps a little strange at first, but what I'm going to do here is I'm going to say that dy is equal to sine of x plus 2 dx. Alright, so basically all I've done at that point is to multiply both sides on this one by dx. Okay, and if I do that, then I'm going to go ahead and integrate this. I'm going to integrate dy. I'm going to integrate this, and I'm doing this for the purposes of leading up to the next lesson, which is going to be separation of variables, which is going to be kind of like this, but a little bit more difficult. Alright, so now at this point I'm going to integrate. So if I integrate dy, I just get y, and if I integrate sine of x plus 2 with respect to dx, or with respect to x, I'm sorry, then what is the antiderivative of sine x? And hopefully all of you should remember your trig integration. So this should be negative cosine x plus 2x plus c. Right, now to find the c value, alright, basically as the vertical shift, to find that out, I'm going to have to plug in a 3 for x and a 5 for y. So I'm going to have 5 is equal to negative cosine of 3 plus 2 times 3 plus c. Now when you do this on the calculator, and obviously I would say please do that, you would get this is equal to 5 is equal to approximately 5.99 plus c, so therefore c is equal to negative 1.99, which means that the solution is going to be negative cosine x plus 2x minus 1.99. Alright, and that's it. Again, if you got any questions, please let me know. And just hang in there. We only have about, about 2 more sections left before the review and test. So hang in there. We're almost done.